Now, you compare this school of thought with something a little bit later, the Athenians, and one of course, the most famous one is Plato. Plato was born in Athens around 429 BC, a student of the famous Socrates. This entire school was hugely influential in the topic of epistemology, which is the study of knowledge. How do we know something? How do we know something is true or not? The foundations of logic. When is an argument sound? When is it not sound? Plato and his students were somewhat disdainful of the idea of materialism. They were very mistrustful of the material world as only a reflection of the true reality. And there's actually a famous analogy called Plato's Cave, where Plato said that humans and our perceptions are extremely limited. We don't perceive the true nature of the universe. And if you picture us all being deep inside a cave, and there's light shining down from the entrance of the cave, and all we see of the outside world are shadows being cast in our cave on the walls. Such is a similar idea of the world around us. There is an ultimate higher divine reality, and the reality we see around us is not a true reflection of that. Interesting idea. And this school advocated pure logic and mathematics can help overcome this handicap. Logic can take you through some of the illusions of the material world. They did a lot of thinking about the stars. They were some of the first people to realize that both philosophically and through experimentation, that celestial objects were spheres, the most perfect shape. Everything below the orbit of the moon, they believed, was made of the corruptible elements, earth, water, fire, and air. And above that, everything was made of a perfect fifth element, the quintessence, the fifth element, the essence of spirit. It may interest you to know that there's actually a reason they thought there were 5 elements, and that had to do with geometry. It shows you how much they loved the idea of pure logic. You can only make 5 solids out of regular polygons, shapes where each of the shape has the same size side and the same angle between the sides. There are 5 of those, and therefore there had to be 5 elements in the universe. So a real grounding in geometry. That's not true, actually. It's a lovely theory. I mean, it's not actually true at all, but they had a wonderful, consistent model. It may seem like modern astrophysics is getting more and more strange. You've probably heard that we now believe the universe is about 99% made of something that we have no idea what it is. And I thought I would talk a little bit about how it got that bad and how we might be trying to solve that problem. A little bit about who I am. I'm actually an astrophysicist by training. That's my doctorate. It's in the spectroscopy of massive stars and the atmospheres of massive stars, magnetohydrodynamic coding, all that great stuff. I did a lot of research on observatories all around the world. I've been a user of Hubble, the Keck telescope, a lot of other things. About 10 years ago, I started accidentally doing television shows. And I really mean that accidentally. I was working at the Jet Propulsion Laboratory, and I think just being close to Hollywood, they kind of grabbed any young woman and said, go talk to people. And I ended up on 3 different television shows. If the show has the word universe in the title, I'm probably on it. I'm on the History Channel's Universe Show, the National Geographic's The Known Universe, How the Universe Works on Discovery Channel, and I also do a lot of podcasting for NASA as well. That's me and my robot companion there, one of my favorite podcasts. These days, as Assistant Director of Science at Goddard, I actually do represent all 4 of NASA's science divisions, which is Earth Science, Planetary Science, Astrophysics, and Heliophysics and Space Weather. So I need to learn a lot more about Earth science. I'm getting educated pretty well these days, but I'm hoping to make it out to my first AGU meeting this December. So I've got a lot to learn. So please educate me. I think I'll definitely need to do that. Plato encouraged the idea that the universe was perfect, and therefore everything in the heavens had to move in perfect circles, and the circles had to have uniform motion, no speeding up or stopping. Now, probably the most famous pupil of Plato was Aristotle. And Aristotle codified a lot of this. So he was famously the tutor of Alexander the Great, one of the reasons we know so much about him, and the father of our current formal logic and the idea of axioms or universal truths proven through logic. He had a wonderfully encompassing philosophical system, natural science, ethics, arts, politics. He had laws for whether these were done well or not. And he was heavily influential all the way up until basically the Renaissance. The idea that the universe was made of nested, perfect spheres that the planets traveled on, and everything in the sky moved in perfect motion. And these are pictures of Mars taken over a couple of different months in 2011 to 2012. Again, you can actually see the constellation Leo in the background. And Mars is doing one of these loops. It actually appears to go backwards and kind of move around the sky. This was called retrograde motion because things were moving backwards in the sky. And one of the big deals with the Greeks was trying to explain what was going on here, because this didn't look very perfect by any means at all. And I have a somewhat long, well, it's only a couple minutes long, but this is an animation of some of the ideas we've had about retrograde motion. And I'll kind of put this through. You start with the Earth in the middle. I mean, that's kind of reasonable to assume that when you're an ancient person, the Earth seems huge and the middle of everything that's going on in the skies. Now, the little ball you see is Mars. And this is a model that was proposed by a man called Eudoxus of Cnidus. And Eudoxus was actually a friend of Aristotle's. They were both students of Plato. And Eudoxus was trying to figure out how you could get Mars to move backwards and forwards while still having everything be perfect circles moving at the same velocity all the time. And there is a way to do it if you nest rotating rings, one inside the other, and then put all of that on a ring that rotates it around during the course of the year. And what Eudoxus thought he had discovered here were sort of the supporting mechanisms under these crystalline spheres, under these perfect spheres the Greeks believed in. It works fairly well for what the Greeks were able to measure back then in terms of planetary positions. Honestly, it never worked all that well, even for them. And fairly quickly after that, we go to an idea called epicycles, which probably most of you have heard of. The first person we know that actually came up with this idea was Apollonius of Perga. And this was refined later by astronomers called Hipparchus and Ptolemy. Ptolemy was an Egyptian who was born in about 90 AD. I actually think that, so this is right around the turn of the millennium we're talking about. And what Ptolemy described this motion, he said, well, it actually gets a lot easier if you assume that Mars is on another little circle that goes around the orbit of Mars we see in the sky. And from the perspective of Earth, you see that as you look out from Earth, you see Mars do these loop-to-loops on the sky as it goes around its little circle there. That circle was actually called the deferent. That was the word they used for it. Now, this model worked fairly well, and actually, that was something that in my last talk about Galileo, people were arguing about, even as late as the 1600s. Galileo was the person who proved beyond a shadow of a doubt this could not work. He had very, very good proof for why it doesn't work. And of course, now we understand why Mars makes this motion. You take Earth away from the center. Now you put the sun in the center. And both the Earth and Mars are going around their orbits. Earth is going a bit faster than Mars is. Both Mars and Earth are moving forward in their orbit all the time. But as we're going a little faster, we overtake Mars. And as that happens, just like if you're driving on a car on a highway and you're driving a little faster than another car, even though that car and you are both moving forward, the car seems to move backwards to you. That's really what's going on.
A star is a large amount of gas and dust that is collapsing under the force of gravity. At first, this crush of gravity makes the inside of the star hot enough to ignite a nuclear explosion. This explosion supports the star against gravity and makes it shine. In our sun's case, this stage will last for about 10 billion years. But eventually, all the nuclear fuel inside the star, mostly hydrogen and helium, gets used up. After that, there's nothing to support gravity, so once again, the star starts collapsing. What happens next depends on how much mass the star had in the beginning, and which forces of nature can finally hold up to the crush of gravity. With stars about the size of our sun, gravity will crush everything tightly together, but eventually the structure of the star's atoms will hold up gravity. Those stars, like our sun, will become white dwarf stars. A white dwarf is basically a big dying cinder about the size of the Earth, and with the density of an 18-wheel truck crushed into the volume of a sugar cube. If a star is just a bit more massive than the sun, not even the structure of the star's atoms can hold up against gravity, and everything gets crushed into one giant atomic nucleus. This forms a neutron star, which is about 10 miles across and has a density of a Mount Everest per sugar cube. If the star is much more massive than the sun, say about 3 times more massive, then nothing can hold up to the force of gravity. The star collapses right out of existence and becomes a bottomless pit that we call a black hole. Nothing can escape the gravity of a black hole. In fact, the reason we call them black is that the gravity is so intense it can actually pull in light itself. So the final death of a star depends on its mass and what, if anything, can stand up to that final crush of gravity that began even before the star started to shine.
Now, it kind of makes sense that if the universe is expanding, was it all much closer together in the past? And this was actually something that was debated by famous people. Here we have George Lemaitre, who was a Jesuit priest and astronomer, of course, Albert Einstein. And it was at a meeting, actually, that George Lemaitre proposed the idea of what he called a primeval atom, that everything in the universe is now expanding away from everything else. Back in the past, that implies there was a time that everything was a whole, one big clump of something. And then it expanded. And the smiling guy there is Fred Hoyle, an English astronomer and a bit of a gadfly. And Fred Hoyle said, well, wait a minute. I mean, do you mean to suggest everything began in a big bang? It was actually meant as a joke. And Lemaitre said, well, yeah. And that's where the word Big Bang comes from. The term Big Bang was actually sort of a criticism as to what George Lemaitre thought. And so you do a search these days. You do a search these days on Big Bang Theory, and of course, you know exactly what you're going to get. And I encourage people to go to the web and look at videos about the Big Bang. But this is always the first thing that... It's not so bad, though, because you may have heard from the bio that I actually was a postdoc at Caltech. So these people portrayed in the show are my friends, and I will say that personally... You know, I don't know how many science fiction costumes I have. We have had the problem of everybody trying to wear the same science fiction costume. That happened. This was actually my research group at Caltech. One time, instead of being regular Star Trek people, we all wanted to be mirror universe Star Trek people, where if you're a science fiction fan, you get the joke. Everybody has a goatee. I loved my goatee. I had so much fun. This is just kind of a fun little aside. It turns out that we're colliding with a galaxy right now, and we never even knew it. This is something we learned from our infrared surveys. The blue stars on this represent the stars of the Milky Way galaxy. And we noticed that if you look at the motion of stars in the sky, there's this weird stream of kind of ripped off stars. And we believe that's actually from the Milky Way absorbing the core of a smaller galaxy that's now almost fully combined with us. It's called the Canis Majoris dwarf. And the fun thing, so here's the sun. The position of the sun is actually quite near some of these strips of stars that were ripped off this other galaxy. In the night sky, we're actually probably closer to stars from another galaxy than we are to the center of our own galaxy. It's kind of a neat idea. Look up in the sky, not all those stars are from the Milky Way originally. So how many galaxies are there? Well, this is a picture from the Hubble Space Telescope called the Hubble Ultra Deep Field, where Hubble looked at a relatively empty part of space for the better part of a month. It just stared at the same part of the sky for a long, long time. And to give you an idea, there are about 2,000 galaxies that you can count in this image, in the original data. And the amount of sky that this represents, I mean, it amazes me. Every little dot you see there is a galaxy, right? A galaxy of hundreds of billions of stars, 100,000 light years across. And the amount of sky that this represents, I have a prop. This is a quarter. And if you look at the eye of George Washington, I realize, yeah, difficult for you to see. But if you look at the eye of George Washington and you hold it at arm's length, that's the amount of sky that this image represents. So we find about 2,000 galaxies in every tiny little pinprick dot on the sky. Each of those galaxies has billions of stars. Based on our current estimates of how many planets are in our own galaxy, the Milky Way, we think that each of these galaxies has up to 100 billion planets. So that's a lot of stuff.